Hello friends, very good morning. In this video, we are going to have a small derivation on the design of a key used in a coupling in the subject machine design 1. Friends, let's see what the question we have for today's video. It runs like this. Determine the length of a key required in terms of shaft dia D if shaft and key are made of same material and of same strength. Same material means they will have the same stress. Same strength means they will be able to transmit the same amount of torque. Friends, here we are required to draw the expression or write the expression for the key, for the torque transmitted by the key and also that of the shaft. Then you will have to equate them and get the relation between L, the length of the key, with the shaft diameter small d. Friends, we will first of all write down the expression for the torque transmitted by the shaft having diameter d. So I'll write down empty shaft means torque transmitted by the shaft is equal to, we have general formula, pi d cube by 16 into eta into tau s. We will call this as expression number 1, where mt is the torque transmitted by the shaft having diameter d with the stress value. S stands for the shear stress for the shaft. So this is the equation we have got, and this is derived from the formula T by J is equal to G theta by L is equal to Fs by R. Fs is the shear stress here, T is the torque that is represented by Mt in most of the uh, books on machine design. Friends, let us see what is the equation for the torque transmitted by the key. So we can say here in general empty key. You can take either the torque transmitted in shear or in compression, you get the same relation for L and D. It is given by the formula empty key is equal to BL tau K D by 2. This is expression number 2, say, where this B stands for the width of the key. The key will be like this. It will have a width B and thickness H, and it will be having a length equal to this L. L is the length of the key, and you have to go through the previous 2 videos on this design of key. So friends, BL tau K D by 2 is the torque transmitted by the key in shear, and tau K stands for the shear stress of the key material. Generally, the shaft, key and bolt will be made of the same material in case of any of the couplings. So here, this tau K is the shear stress for the key, tau S is the shear stress for the shaft. And what does he say in the question? It is said that the shaft and key are made of same material and of same strength. When it comes to strength, it means that the torque transmitted by both the elements is the same. So I have to equate expression 1 to expression 2. That is to say, m, that is pi d cube by 16 into eta into tau s is equal to BL tau K into D by 2. I have just equated equation number 1 and equation number 2. Now we have to just cancel some of the terms like this. So this can be, because D is here, D cube is here, I will say this is pi D square by 8 by cancelling these 2 multiplied by eta multiplied by tau s is BL tau K. This is what the expression we get after you cancel this term D here. Friends, this D is the diameter of the shaft. Eta stands for the key wave factor. So I would like to say little information about this key wave factor. Friends, if you have got 2 shafts, one a solid shaft, other one the same diameter shaft, on which a key slot is cut on the outer periphery. Both will have the same dia. And you know very well, when a key slot is cut on the shaft dia, because of the removal of the material, the strength of this, which has got the same dia as that of the solid shaft, will be able to transmit lesser amount of torque compared to that of the shaft without key slot on its periphery. So here this reduction is indicated by this factor, key wave factor, and is generally taken equal to 0.75 to zero point 0.8. That means, in other words, a solid shaft, that is a shaft without a key slot, will be able to transmit 25% of torque more than that of a same diameter shaft with a key slot. Or in other words, a shaft with a key slot will be able to transmit around 75% of the torque compared to, so those of the shaft have got the same dia, but only difference is there is a key slot cut here, there is no key slot. This will be able to transmit 0.75 times the power transmitted by this. So I take this factor as 0.75. Pi d square by 8 multiplied by zero point 0.8 or 0.75 you can take, doesn't matter, into tau base is equal to BL into tau K. Friends, a thumb rule says that the value of B is generally d by 4. Or you can say, so this is d by 4 multiplied by L multiplied by tau K. With this assumption, friend, we can cancel this tau base and tau K because the shaft and key are made of the same material. And friends, if you simplify this, you will be able to get the expression L is equal to 1.178 D, or generally L is equal to 1.18 D. That is, when the shaft and key are made of the same material and have the same strength, the relation existing between L, the length of the key, and the diameter of the shaft is L is equal to 1.18 D. It is one of the important derivations asked on the chapter design of key. Friends, please go through the complete video. If you like this video, do share it with all your friends without fail. Thank you very much for watching my YouTube video. Have a blessed day.